Teaching skills like robotics and AI is absolutely crucial today. But what happens when the tools you need to learn this stuff cost a small fortune? Well, today we're going to dive into a pretty big challenge in global education and see how one curriculum is basically hacking the system to bring these amazing tech skills to everyone. And this really gets to the heart of the problem, doesn't it? When the hardware you need to get your hands dirty has a professional price tag, it just puts up this massive wall. So is the tech that's literally shaping our future only for people who can afford it? Let's break down just how high that wall can be. Okay, first up, the high cost of learning. To really get why the solution we're about to see is so clever, you first have to understand just how big the problem is. So let's take a look at the kind of pro-level gear that's usually considered the gold standard for a course like this. So this little board right here, the Arduino Portenta H7, it is an incredible piece of tech. I mean, it's super powerful. It's an industry standard for something called tiny machine learning, which is basically running AI on tiny, low-power devices. It's an amazing thing to teach with. But all that power comes with a pretty hefty price tag. Let's look at the actual numbers. The board itself, about $114. But then to really use its camera and all its wireless features, you need this thing called a LoRaVision Shield. That's another $69. So the total for just one student is over $180. Now just imagine trying to buy these for a classroom of, say, 30 students. You can see how the costs just spiral out of control fast. So how in the world do you solve a problem like that? Well, the educator behind this, Jeremy Ellis, he tackled it not just by hunting for cheaper parts, but by completely rethinking the entire philosophy of the class. The focus shifted from training future engineers to empowering present-day makers. And this quote, this just says it all perfectly. The course is all about getting your hands dirty, about practical problem solving. It's designed to empower students to make things, to tinker, to experiment, and to really learn by doing, instead of just focusing on the heavy theory you'd get in a university engineering program. So what does that actually look like in the classroom? Well, instead of these easy plug-and-play kits, students are really pushed to think for themselves. They have to draw their own circuit diagrams, which forces them to actually understand what's connected to what. They're encouraged to get creative when a new sensor doesn't have a simple connector. It's really about building that deep understanding right from the ground up. And this isn't just some academic exercise, it's all driven by a really important global mission. The person who developed this curriculum is part of a group called TinyML4D, and they're dedicated to bringing this kind of education to students in developing countries. And for them, a $180 kit isn't just a pain, it's a complete non-starter. So, with that Maker First idea as our guide, let's finally look at the affordable hardware that makes this whole thing possible. Okay, here's the secret sauce. Instead of that $114 board, the curriculum uses the Seed Studio Shao, which costs about $14. And the second board, the Rack Wireless Sticker Tracker, is around $15. So the grand total for one student, get this, it's under $30. That is an absolute game changer. Let's really put that into perspective for a second. For what it would cost you to buy just 3 of those expensive kits, you could get more than 15 of these affordable ones. I mean, think about that. You can outfit an entire classroom for less than what it used to cost for just a handful of students. The impact of that is just enormous. But of course, there's a big question, right? Does affordable just mean less powerful? Are you sacrificing real deep learning just to save a few bucks? Well, let's take a look. Oh, not at all. The learning path here is totally comprehensive. It really takes students on a complete journey. You start with the coding basics, you move into sensors, you dive deep into machine learning, and then you cover things like actuators and the Internet of Things, all leading up to a final project that they build themselves. And the skills we're talking about here are absolutely cutting edge. I mean, they're working with GPS, accelerometers, even LiDAR for distance sensing. They learn to control motors, and maybe most impressive of all, they build real machine learning models using professional tools like Edge Impulse. Trust me, this is no watered-down experience. So when you step back and look at all this, what's the big picture? Well, this whole approach is really about democratizing tech education. It's about so much more than just saving a bit of money. The Maker100 approach is really all about tearing down that financial wall. By making these powerful tools truly accessible, it empowers so many more schools, more teachers, and most importantly, way more students to stop just being consumers of technology and actually start creating it. So, what should you really take away from all this? Well, first, affordability equals access. It just opens the door for so many more people. Second, that maker first mindset leads to a much deeper, more practical kind of learning. And maybe the most exciting part is that this proves powerful, advanced education doesn't have to be ridiculously expensive. Which kind of leaves us with one last big question to think about. This was all about robotics, but the principle behind it could apply anywhere. So what other fields, in science, in art, in technology, are locked behind a similar high-cost barrier, just waiting for a maker-focused revolution to come along and unlock them for everyone?